Now let us look at the next special case, that is circle. For that, let me take E0x as 2, E0y as 2, phi x I'll keep it as 0 and phi y as 1.57, and lambda let me increase a little bit, speed also little bit change, or lambda let me decrease it further to make it more easy to visualize. It looks like this. It is a circle. So I can, as you can see, the circle is in magenta color, which means it is counterclockwise. This is the resultant wave, and as a function of time, this is the time slider. It is moving counterclockwise, and here you can observe this line with respect to this line. It gives a sense of movement. Also look at the phase difference when Ex is maximum, and Ey would become maximum at quarter of a period later. So Ex is ahead of Ey. That is the meaning of this phase difference, and we can see in the vector diagram. And when Ex becomes 0, this is 0, Ey is maximum. So let's look at this for a full wave. So this is circularly polarized light, where the vector rotates in a counterclockwise direction, which is referred to as left circularly polarized light. For circularly polarized light, E0x and E0y must be equal, and the phase difference should be pi by 2 or 3 pi by 2. We are looking at a phase difference of pi by 2, which leads to a left circularly polarized light. Now let us look at the right circularly polarized light, for which the phase difference is 3 pi by 2, that is 4.71 radians. So now the color has changed. This is a clockwise rotation. And also look at the phase difference when Ex is maximum at this point. E0y would become maximum after 3 pi by 2 radians. Let's look at this. So this is Ex is maximum here, and as a function of time now, the time slider changes. So this is the maximum of Ey. So this is the maximum of Ey when Ex becomes 0. So this vertical line, reference line, is not same as this one. There is a small shift, that's why they are not going to 0. See, this is the point, but this is not going maximum, but this is maximum. So this is not that reference line. That reference line could be here. I have one more line. I can shift it here. Let's look at this. Let me put it Ey is equal to maximum somewhere here. Yeah, so with this reference line, this would match. Ey is maximum, Ex is 0. So let's look at this. Now Ex is approaching maximum. We're almost there, and Ey is 0. So let's observe this for a function of time. So the sense of rotation has become clockwise, the right circularly polarized light. So at all times, the resultant vector, the tip of the resultant vector would draw a circle. So this would happen when E0x and E0y are equal and phase difference is 3 pi by 2, that is 4.71 radians. That is Ex is ahead of Ey by 3 pi by 2 radians. It would be interesting to split the circularly polarized light into Ex and Ey in 3 dimensions. Let's have a look at it after this simulation. let me put this and this. So this is what it means. If this is circularly polarized light, this is Ex and Ey. Let me take some time snapshots. Now let's look at the most general case of ellipse when phase difference is neither 0, pi or 2 pi or 3 pi by 2, any other angle other than that. Let me put 1 radian. So this is the elliptically polarized light, and we can see when the maximum occurs, there is some distance between the maximum of Ey to Ex, which is 1 radian. Or if it becomes 1.5, because 1.57 is circle, so it's almost like a circle. 2, let's observe this. So the sense of rotation is counterclockwise, that is left polarized. To have a better observation of this, observe this point with respect to this line. We can see the wave moving ahead because this is the positive z direction. So at phase difference 0, it was a straight line, and as the phase difference increases, it becomes more and more bulged ellipse. At 1.57 it becomes a circle, and after 1.57 it changes its orientation. Earlier it was making an acute angle with the x-axis, the major axis of the ellipse. Now it is making an obtuse angle with the major axis of the ellipse. For 2.5, now the ellipse will start shrinking with the obtuse angle with respect to x-axis. 2.5, 3, it's a very thin ellipse, and 3.14, it becomes a line. And after 3.14, let me put 3.2. Till now, from 0 to 3.14, the color was magenta. It was counterclockwise or left polarized. Now the color has changed. That is, now it becomes clockwise rotation. That means the polarization becomes right polarized. And if I further increase, the bulginess increases. At 4.71, remember it became a circle. Let us observe this. So there is a clockwise rotation. The phase difference is 4 radians. And as the phase difference further increases, at 4.71 this becomes a circle, and after 4.71 it again becomes ellipse, making an acute angle with x-axis. Nevertheless, the rotation will be clockwise. So the 3D diagram is more difficult to understand. Nevertheless, this is what actually happens. The green wave is the actual field, and their components can be visualized in red and blue. It is more instructive to look at the two-dimensional graphs and the polarization graph. So at 4.71 we have already seen it is a circle. At 5, again it becomes a bulged ellipse, making an acute angle. Let me give some time snapshots. .5, Now it starts shrinking. 6.1. So at 2 pi it is same as 0, hence it will become a straight line. So let's summarize. So in this video I have presented the decomposition of a general state of polarization into two plane waves oscillating in two perpendicular directions, and the ratio of the amplitudes and the relative phase determines the combined state of polarization. So if for easy visualization, let me put a unit circle where Ey by Ex is 1, and if the relative phase difference, if the phase difference is 0, the resultant would be a plane polarized light making an angle of 45 degrees with respect to x-axis, and if it angle is 45 degrees, it results in an elliptically polarized light. If phase difference is 90, it is circularly polarized light, left-handed. 135, elliptically polarized light making an obtuse angle with x-axis, and at 180 it becomes again linearly polarized light making 135 degrees with x-axis. So for all these angles from 0 to pi it is left-handed, and from pi to 2 pi the shape of the polarization is same with their corresponding angles. This is same as this, this is same as this, and this is same as this, except for the sense of rotation. So here the blue meaning left-handed and red meaning right-handed. So that's all for visualization in this video. Please look forward for more videos on waves, and particularly in the coming days more videos on polarization concept. Thank you for watching this video.